Hi everybody, P-Brain here. This video is about the fact that a horizon will form on a flat plane like our flat Earth. You know, there's still people, ball earthers, putting out these videos where they show like this, where you see buildings beyond the horizon or boats beyond the horizon, and the lower portions of these objects have their bottoms blocked. And they claim that that's exclusive to a ball earth and curvature, things going over the curvature. Well, what I want to show is that this is also consistent with flat earth and a flat plane due to perspective convergence. Okay, so what I like to use is this simple brick wall right here, and anybody can do this. Actually, there's a flat earther a while back who put out a video talking about the horizon, and he said that, you know, he found a physicist, you know, I guess to give some credibility to the argument, you know, and supposedly if this physicist said that yes, a horizon will form on a flat plane. But what I want to show is it's not that complicated. You don't need a physicist. You don't need someone to verify. Just find this brick wall or any wall with horizontal parallel lines. Okay, but the brick wall, anybody can find one near their house and go and do this experiment. So squat down and then raise your eyes up to each mortar line, right? And as you can see from this picture, they're all going to converge at a point in the distance, right? So that point in the distance is your horizon. But anyway, so raise your eyes up and you'll see that wherever your eyes are is always going to be a horizontal level line, or it's your horizon line, right? So I put the blue line here as I raise up to keep showing you that the higher you get, your horizon stays with you, and all the other lines converge to it, to your horizon line. Okay, so then how does a horizon form on a flat plane, and how would it actually block objects beyond the horizon? Okay, well, being that you can see that everything goes to your eye level, and this wall could be 500 miles high, 1,000 miles high, it doesn't matter. If the plane is big enough to not get to the edge of the plane, if it's a huge plane, the horizon will rise to your eye level. That's just how it works. This is fact of how our vision works, right? Our one-point perspective. So the way the objects get blocked is, as you can see, like I put the wall next to this water and this Chicago skyline, I believe that is. I'm not sure what that is. But anyway, the water ramps up just like these lower lines, these lower mortar lines on the brick wall. And when it meets your eye line, it also simultaneously meets the sky, right? Everything converges there, the sky and the ground. Now, here's the important part. The ground is on this upward trajectory, right? You can see it, right? You can see the surface of the water going up, and it will stop, as evidenced by these P900 zoom cameras. They zoom in, you can see the horizon, and you can't see any more ground past that point where the horizon forms. Now, this is important because this happens on a flat plane, as evidenced by this brick wall, right? And perspective lines, convergence lines. Everything converges to a point. So the fact that you can't see any more ground after that means that, well, let's say you have a building just on the other side of this water horizon. And what will happen is ball earthers will say, oh, you can't see the bottom ground level of the building, therefore it's curvature. No, what happens is if you can't see any more ground due to perspective, like I've just showed you here, that the ground and the sky meet, and you can't see any more ground, what if an object is sitting 10 feet behind that horizon? Well, we know for a fact, based on this, you're not going to see the ground. That's for sure. So if you're not going to see the ground, then there's a chance you're not going to, and this is logical progression, there's a chance you're not going to see a little bit of the bottom of the object that's sitting on the ground either, depending on how far away it is or how far beyond the horizon the object is. So what would happen is you could have a building just behind the horizon, just behind it, right? And only the bottom few inches of the building is cut off. You can't see any ground. We've already determined that past the horizon you can't see any more ground. So take that same building now and move it a mile beyond the horizon. Now the building has gotten smaller relative to the horizon. See what I mean? So now a much bigger portion of it is blocked from the bottom up. And now move that building another mile beyond the horizon. And it keeps getting smaller relative to this blocking horizon. And I know a lot of ball earthers think that you should be able to see forever on a flat plane. Well, besides perspective, there's also miraging that takes place on the surface of the water. There's atmosphere, there's water droplets. You can't see anyway. When they zoom in on boats and stuff that are far out to sea, they disintegrate because of so much atmosphere, right? And then there's the problem of maybe how far light can actually illuminate your horizon. But barring any of that, as long as all conditions are right, the horizon will rise to your eye level. And when it does, you can't see any more ground past that point where the ground has converged with your eye level, because the sky and the ground have converged. Okay, so just reiterating, so we agree you can't see any more ground. Therefore, objects sitting on the ground already have some of them is already blocked, right? Because you can't see the ground. And it makes sense that the further away they are relative to this eye-blocking horizon, remember the horizon forms right in the center of your eye. So you already have part of it blocked already, part of your vision, because it forms in the center of your lens, your eye lens. So anyway, so again, you don't need a physicist. Just get a brick wall like this, move your eye up and down or grab your camera and do like I did, and you'll see all the lines converge on your eye level. And your eye level shows you where the horizon is. That's the level line. And so when I put these two together, you can see the ground here, the concrete sidewalk, represents the water ramping up. And when it hits your eye level line here, it's going to stop. So anything that's on that sidewalk, if this sidewalk went for a few miles, anything beyond it, you'd zoom in, and the bottoms would start to get chewed up. They'd start to get blocked from view. And the further back that object is past the horizon, the more of it gets blocked. Okay, I hope this puts an end to it. A horizon will form on a flat Earth, so I don't want to see any more videos from ball earthers showing us, look, evidence of the curvature. Look, the building over the horizon is evidence of curvature. Oh, and one more thing I almost forgot. This would be, as you look out towards the horizon, that's your z-axis. That's your longitudinal axis. That's from your eye out, right, in any direction. So if they're claiming curvature on that axis, what about the horizon or the horizontal axis, your x-axis? Well, we don't see any curvature on that. So it's ludicrous to say that you see curvature on the z-axis but not on the x or the horizontal axis. That's just another point. So that confirms that what we're seeing is a perspective horizon. It's not a curvature horizon. Okay? All right. Thank you so much. That's it for now. All right. Bye.